So basically, we are talking about what? Vector product or cross product. And we said vector product is another form of what? Vector what? Multiplication, right? Now, if we were to consider vector product or your cross product, what do you see to say, oh, this is a vector product, or basically this is a cross product? I told you when you have two vectors and you want to represent it with a vector product or a cross product, what you use is your multiplication sign. So when you see this sign, you should know that okay, this sign is telling you that we are considering what? A vector product. Now let's consider a vector product while we are talking about this in a plane. Remember, we are considering what? A Cartesian plane. So if you want to consider your vector product while talking about your Cartesian plane, you need to consider the two concepts involved. Now, what are the concepts? In a plane where we have two parameters with the same quantity, what do I mean? I'm simply saying if you have in a plane where you now have two parameters with the same quantity, I mean when you have I cross what? I. What's the concept involved? Now take down for this concept, for your first concept, which you have parameters with what? The same quantity, you simply have this to be equal to what? Zero. Now, what's the second concept? The second concept is applicable when you have parameters with different quantity. So basically, if you have I cross what? J, what will it be? So your I cross J will simply give you what? K. So what we do is we use this to represent each of these unit vector such that when we do our multiplication and we find out that we have I dot I or I cross I here, we should know what to use to represent it. Are we together? So basically, if we now have I cross what? K, what will it be? Now your I cross K will simply give you what? Minus J. So these are the concepts you need to note. You need to have it in mind that okay, when you see this, you should know that we use this to represent what we have here. Are we together? Now, what's the next thing? The next thing is when you now see J cross what? I. What is J cross I? Your J cross I simply tells you that this is what? Minus K. So anywhere you see what? J cross I, you are replacing J cross I with what? Minus K. Now let's move to the next one, which is J cross what? J. Now remember, J cross J, I cross I here is simply what? Zero. So what do you think J cross J will simply be? It will also be what? Zero, because you have the same parameter with the same what? Quantity. Are we together? Now what's the next one? J cross K. What's J cross K? Your J cross K will simply be what? I. So anywhere you see J cross K, you represent it with what? I. Are we together? Now let's consider the K component. For your K component, you simply have K cross I. What's K cross I? Your K cross I will simply give you what? J. Next one is what is your K cross what? J. And your K cross J will simply give you what? Minus what? I. Now what's the next one we are to consider? K cross what? K. Now, what's your K cross K? Your K cross K will simply give you what? Zero. So what you should note that is for your diagonals, you simply have your diagonals here to always be equal to what? Zero. So wherever you are seeing I cross I, J cross J, and K cross K, you should know that those parameters will give you what? Zero. Are we together? Now let's take an example. Let's say we are given two vectors a and B. Your A vector is given to be AXI plus what? AYJ plus AZK. And you're given another vector to be BXI plus BYJ plus what? BZK. What is now A cross B? These are your question will now come. They will ask you, show that A cross B is a what? A vector. Are we together? Now, how do you do this? The first thing we do this, for you to calculate this, there are two methods we use in calculating this. Now, the first method is what we call the multiplication method, or basically the first principle method. So we call this multiplication expansion method. I will call it multiplication expansion method. While the second method is what we call the matrix method. So what you do on the second method is to use the concept of matrix, the normal concept of matrix we do in our elementary maths to solve problems like this. Now let's take the first method, which is what multiplication expansion method. What do you do when you have A cross B, right? Now, for we to answer that particular question, let's go over to a new page. We are simply given to find A cross B, right? And they said show that A cross B is a vector because you are using your what? Your vector product or your cross product to solve. Now, we were simply given AXI, right? Plus AYJ plus what? AZK. And this is multiplying what? BXI plus BYJ plus what? BZK, right? Now, what do you do? Remember, what we have here is we want to use the first method, which is expansion, multiplication expansion, or we are basically using the concept of, okay, let's take down, if we have 2y plus 3x and we have another parameter 3y plus 4x, 4x. Now, what do we do? Normally, what we do is we use one bracket to multiply the other bracket. So what we simply do is we use this, we multiply this, we also use this to multiply what? This. After doing that, you now have your plus sign. You now use this to multiply this, plus you now use this to what? To multiply this. So the same thing applicable here, the same concept. You apply the same concept. So what you are simply doing is you use this parameter to multiply this, you still use this to multiply what you have here, and you still use this to multiply with what you have here. After finishing with your first parameter, you move over to the second parameter and you apply the same step, right? So now from what we've gotten here, the first thing you do is let's do our let's apply the multiplication expansion method, or basically a multiplication expansion what? Concept. Now, for you to apply that concept, what's the concept? The concept simply says use this to multiply everything we have here. Now, if you do that, you simply have AX multiplied by BX here. So you simply arrive at what? AX, BX, and what's happening to their unit vector? You simply place their unit vector one side because that's our interest. So we have I multiplied by I here. So this will be I cross what? I. Are we together? Now, what's the next thing? The next thing is to move over to the second parameter here. The second parameter is what? BYJ. So what you are simply doing is you are using AXI to multiply with what? BYJ. So that will be plus AXI. So this will be AX plus what? BY. And what's your unit vector? I cross what? J. Are we together? Now apply the same thing with the next parameter there. So it will now be A. You simply have AX, right? AX what? BZ multiplied by your I cross K. Are we together? So we are basically done with the first one. The next thing is to move over to the next parameter here, which is what? AYJ. Apply the same concept. So you are using this to multiply this. You are using this to also multiply this, and you're also using this to what? To multiply what you have here. Now, if you do that, that will simply give you what? You simply have AY, right? BX, but in this case, you now have J cross what? I. Plus, we are using this to multiply what we have here. So that will give you AY, BY, right? So what will you have as your unit vector? J cross what? J. Plus, the next one will be AY, right? AY what? BZ into J cross what? K. Are we together? So basically, you've used this to multiply with what we have here, and you've arrived at this parameter here. So we'll now have our plus. You move over to the next one. You use this to multiply this, use this to multiply what? With this, and also use this to multiply with what you have there. So basically, what are you doing? You are actually applying the concept of what? Expansion, multiplication, or how will I we are going to call it expansion by what? Multiplying. So we are actually expanding by what? Multiplying. Are we together? So basically, if you apply this concept here, this will simply give you what? Az bx k cross what? I. What's the next thing? Plus you have az b what? Y. Then you now have what? K cross what? J. Now the next thing, the final parameter will now be plus what? Az. So you have az multiplying what? Bz. So this is bz k cross what? K. Now look up. Our interest is what? Our interest is our unit vector. Since we've already gotten the plane for your unit vector. So what you do is look at your unit vector. What are you having here? You are having what? I cross I. Go over to your unit vector. Going over to your unit vector, what do you have here? You have your unit vector here to simply be what? I cross I. So anywhere you see I cross I, you are imputing what? 0, right? So anywhere you see I cross I, it is what? 0. Anywhere you see J cross what? J cross I, it is what? Minus K. So you apply that concept here. Applying that concept here you simply have this to be what? 0. This to be 0, right? What's the next one? The next one is you're having I and J. Go over to your plane. From the plane given, you have your IJ. IJ is what? K, right? So if IJ is K, we'll come here, you impute this to be what? K, right? So what's the next one? IK. And what's your IK? Now your IK is simply what? Your IK is simply what? Minus J. So you go over to your IK here, this will be what? Minus J. Now what's the next thing? Ji. What's your Ji? Your Ji was simply what? Minus k. So you have minus k, 0 and I. So what you have here, this will simply give you what? This will simply be minus k, 0 here, and what? I, right? So the next thing we have there on our list for our plane, we have kj, right? So here we have ki. What's ki? So you go over to your plane, you look for what ki is. So we are taking this and we have what? J minus I and z. So you go and represent that with what? J. This is J minus I and what? 0. Are we together? Now what's the next thing? The next thing you should ask yourself is, since this is equal to 0, anything multiplied by 0 is what? 0. So what you have here will simply what? Be what? 0, right? Now what are you seeing here? Instead of having ax bx I cross j, what you simply have is we are using this to represent with what we have here. So instead, this will now be what? Since this is, remember your I cross what? This is I cross j. So let's confirm. Your I cross j is k, right? So since you have I cross j here, your I cross j will simply be what? K. So this is k. So instead of using this, we are using k to multiply everything here. So if we do that, we will simply arrive at what? Ax by with the unit vector what? K. Are we together? Apply the same concept to the next parameter there. So if you apply the same concept there, this is minus j, right? So this minus is going to affect what we have here. So if this minus is affecting what we have here, we'll simply have this to be minus ax b what? Z of what? Of j. So you can see that you have a minus sign here. So what if you want to expand? If you're expanding this minus, then you simply have plus multiplying this minus, and this will give you what? Minus sign. So we can take this to be our larger minus sign here. Now go over to the next one. We are simply seeing j cross I. What's j cross I? J cross I is simply what? Minus k. Let's confirm. So you simply have j. Where is our j cross I? So j cross I is what? Minus k. So since we have minus k there, your minus k is going to affect your positive sign here. If minus is affecting your positive sign, then you now have this to be what? Minus, because minus times plus is minus. So since you're having minus here, it will now be what? Minus aybx of what? Of k. Are we together? Now go over to the next one. What we have here will simply be what? 0, because I cross j, sorry, because j cross r and j cross j is what? 0. So anything multiplied by 0 is what? 0. Let's go over to the next one. The next one is j cross k. We said j cross k is represented with what? I. So instead of using j cross a, we are now using I to multiply with what? Ay bz. So what we have here will now be what? Plus ay bz of what? Unit vector I. Let's go over to the next one quickly. The next one we have what? We have j here, sorry. So since we have j here, we are using j to multiply with what we have here. So basically, this is not existing anymore. But what is existing now is what? Your j. So basically, what you have here will be what? Plus az bx of what? J. Now let's consider the last one. Is it the last one? Yes, it's the last one because what we have here is what? 0. So since this is the last one and we have minus here, your minus is going to affect the plus sign here. So if it's affecting the plus sign here, this will now be what? Minus what? Az by of what? Of subscript I. Now look at your answer you've gotten. You can see that your answers are having what? Like terms. Like terms, right? So since they are having like terms, take all those like terms that are similar or they are looking alike together. What do I mean? Those like terms with k, keep them one side. Those like terms with what? J, keep them one side. And those like terms with what? I, will keep them one side. But basically what we are going to do is we are going to rearrange this in alphabetical order. When I mean alphabetical order, I mean your I comes before your J comes before your what? Your K. That's the meaning. So rearranging this in alphabetical order, we are simply picking those with I one side, and we are picking those with what? With J one side, right? So if we do that, which values are we seeing that is having I? So we can see basically this is having I here, and this is having what? I here also. So what do you do? We are simply picking this and this. Now if you pick that, this will simply give you what? This will simply give you AY, right? AY BZ, that's what we have here. So since this is having I, this is also having what? I here. So what will it simply give you? This will now be what? Minus AZBY of the unit vector I, right? What's the next thing? The next thing is look for those vectors with J. Look for the vector with J. Now looking at the vectors with J, we have this with J, right? And we also have this with what? J. So what do you do? Remember what you have here is having a minus sign here. Is having what? A minus sign here. So this will simply give you what? This will simply be plus. This is minus sign here. This is what you have here is having a positive sign here. So what will they give you? This will simply give us what? So we are starting with minus here. So this is minus, right? So if you have minus here, this will simply give you what? Into ax bz of j, right? Now remember, we are having a minus sign outside. So what are we doing to this positive sign that when we expand, it will still give us what? A positive sign. Meaning instead of putting a positive sign inside, we are putting what? A negative sign, such that when you use this minus to expand and you expand, you have a minus sign here, such that minus times what? Minus will give us what? The plus sign here. Are we together? So basically this will now be what? Minus AZ bx of our unit vector j. What's the next thing? The next thing is considering our k component. What are we seeing to be our k component? We are seeing this and we are also seeing what? This. So what do we do? This will simply give you what? Plus into the bracket. What's the first component we are seeing? Ax by. So this will give you ax by, right? What are you seeing here? We are seeing minus here. So this is minus aybx. So this is minus ayb what? X. So if you have aybx here, this will be the unit vector of k. Now look up. What are you seeing? we are basically seeing your vector. We've already finished our calculation, but I want you to note something. You're basically seeing your answer having what? Magnitude, which is what we have here, with what? A direction, which is what we have here. So basically, you've succeeded in showing them that A cross B is a what? A vector, telling you that you have what? Magnitude and direction. Now let's use the second method to confirm if what we have here is the right answer. And what's the second method? The second method is basically our what? Our matrix what? Method. Now take down matrix method. For your matrix method, what we simply do is our interest is what? IJK. So your interest is what? I what? JK. Now what you simply do is the first thing you do when you want to to solve problems using what? Your matrix method. The first thing you do is to assign your what? To assign your the first thing is to assign your symbol. Now, what are the symbols we are seeing here? The symbol here, if you want to assign a matrix, what we do is plus, minus, plus, right? So if you have plus, minus, plus here, you simply draw your column and your row. Now, matrix is telling us that we have our I, we have our J, and we have our K. Now, what is this telling you? This is telling you that each of these unit vector will be having their own what? Column, right? So if this is having their own column, remember what we are to solve is what? What we are solving is what? AX, AY, and what? AZ. So we use this to represent each of the rows of our unit vector. When I mean row, I mean we are using that to represent each of these rows here, right? So if we do that, we are simply representing this to be what? AY here, AX, sorry. Here you simply have AY, and here you simply have what? AZ. Now, what's the next thing here? The next thing is what? You have BX, you have BY, and you have what? BZ. Now, what is matrix telling you? Matrix is telling you that when your interest is now what? Your I component. What you do is you are simply covering your what? Your I column, and your focus will be on the remaining column, which is what? J and K. Now let's assign our symbols first. We have plus, minus, and plus. That's the first thing you do. Now, since our interest is on our I component, so we basically put it down to be for your I component, the concept is you are covering your what? Your I column, and your interest will be your J and K. So what you simply have here will now be what? AY, BY, AZ, B what? Z. That's what we'll do. The next thing is, look at your symbol here is what? A subtraction sign. So you have minus J, who is the next one. And if our interest is on J component, we are covering what? We are simply covering J. And what are we seeing? We are seeing I component, I colon, and what? K colon. So this will give you AX, B what? BX, and this will also give you AZ, B what? BZ. Now, what's the next one? The next one is your K component. So if we are to consider your K unit vector, we'll simply have this to be plus, because this is the plus we have here, plus K into the vector. So we are basically covering this. What are we seeing? We are seeing AX, AY, BX, BY. So what you have here, you simply have AX, BX, and you have AY, B what? Y. So that's the concept. Now, what is the next concept in matrix method? The next concept is when you want to do your multiplication, you simply do what? You take this, you multiply this, then you go over and you multiply this. Are we together? So what you will do first is you multiply with this, then you multiply with what? With what we have here. That's the concept when we are talking about matrix. Now, if you do that multiplication concept, you simply have this to be I, AY multiplied by what? BZ. That will simply give you what? AY BZ minus, what's the next concept? We are using this to multiply with what we have here. So if you do that, you simply have AZ multiplied by what? BY. And this will give you AZ multiplied by what? BY. So this is the first one we have here. Now, what's the next thing? The next thing is you have minus J here. So since you have minus J, you can represent this to be minus J. So this is minus J. So since you have minus J there, AX multiplied by BZ. So this will give you AX BZ, right? Minus what we have here multiplied by this. So that will give you what? AZ B what? BX. Are we together? So now what's the next thing? The next thing is to go over to your K component here. So you have plus what? K. Now applying that concept for your K here, you simply have this multiplying this. So you have AX BY multiplying what? Minus AY B what? BX. Now look at what we have here. Looking at what we have here, is this telling us that it is a vector value? Yes, it is a vector value. Why? Because we have what? Our magnitude and also what? Direction. That is why it is what? A vector what? Value. So that's how to solve problems dealing with vector product or what? Your cross product. Since we've gotten the answer using your matrix method to calculate, let's confirm if what you have as your matrix answer, is it the same with what you calculated for using your multiplication expansion method. Now let's confirm that. Remember when we did that, we have AYBZ AZBY. So we are going to confirm. So here you have AYBZ minus what? AZBY. Now looking at what we have here, we'll still arrive at the same answer with what? Using our multiplication expansion method to solve. Now you can see that each of these methods you use to solve, you still arrive at what? The same what? Answer. So it's left for you to look for the method that is more easier for you to use, or better still, more convenient for you to use.